Hey, ladies and gentlemen, this is Miss Humbert here, and we're going to be doing Unit 7, Notes 3. So we're going to be talking about measures of angles and arcs. So first we need to talk about what a central angle is. A central angle is an angle with the vertex at the center of the circle. Okay, so if you notice on the other side over here, and if my whole writing would show up, that'd be fantastic. So it's the vertex at the center of the circle. So B is at the center of our circle, and it has two radii that make up the sides of the angle that extend to the end of points of the circle. That makes it a central angle. So now we need to find the sum of central angles. So the sum of central angles will take the measure of the first angle plus the measure of the second angle plus the measure of the third angle, and all of that needs to be 360 degrees. Circles always add up to 360 degrees as you go around. So all of your central angles need to add up to 360 degrees. So let's take a look at number 1. So we know that x plus 165 plus 145 needs to be equal to 360 degrees. Well, there's another way we can write that. X is going to be equal to 360 minus 165 minus 145. So you can go ahead and subtract all of those. And when you do that, you end up getting 50 degrees. Now let's take a look at number 2. So for number 2, it's the same thing. Let's just do it the easier way where it's already solved for x. So x is equal to 360 minus 85 minus 40. Remember that this little square means it's 90 degrees, so then minus 90. So when you subtract all of those out, you end up getting 145 degrees. So that angle is 145 degrees. Now, whenever we're talking about angle measure, you want to make sure you label it with degrees, okay, because it does count. So let's take a look at the different types of arcs. So a minor arc is the shortest arc connecting 2 points. So the shortest distance between A and B along a circle is that short arc right there. Minor arcs are always less than 180 degrees. Okay, so we can say that the measure of arc AB is equal to x degrees, okay, because the central angle measure is equal to the arc length when we're talking about a minor arc. Now, taking a look at a major arc. For a major arc, we're going to take the long way around to get from A to B. We're going to take the long way around. So what we do, first of all, we know that a major arc needs to be greater than 180 degrees. To signify a major arc, what we usually do is we throw another point in the middle. So this should be A, D, B. So that tells who's ever looking at it that you have to go through the point D, which tells them to take the long way around. Okay, and so then to get the measure of that arc length, you just take 360 minus this angle, which makes sense because that will give us that outside portion. All right, let's take a look, at this next one. So for the semicircles are going to be equal to 180 degrees. So it doesn't matter which way you go around on this one, it's equal to 180 degrees. So the arc length ADB is going to be equal to 180 degrees. And it's also 180 degrees going the other way around. So let's take a look at some of these examples. Let's take a look at number 3. We know that GH, okay, so because it just says GH, we're going to assume we're taking the shortest way around. Well, the central angle is equal to the arc length. So for GH, first of all, it's going to be a minor arc because it's only 122 degrees, and that's less than 180. Next, it wants us to find the measure of LH. So now we need to start at G and we need to go through point L. So we have to go all the way around this way. So to get that, first of all, I see that it's greater than 180 degrees. So whatever the measure is, it's going to be a major arc. So to get the measure, I'm just going to take 360 minus that 122 that I already know. So then we end up getting 360 minus 122. Oh, excuse me, I am really struggling with my cold. Okay, And then you end up getting 238 degrees. Last but not least, we need to calculate out the measure of GLJ. So we're going to go through L, that's the direction we're going to go to get to J. Well, I notice that this is half of a circle, so it's a semicircle. And the measure is going to be 180 degrees for number 3. Next, let's take a look at Theorem 10.1. If the same circle or incongruent circles, two minor arcs are congruent if and only if their central angles are congruent. So what does that mean? So what we're saying here is that if we know that the measure of angle 1 is congruent to the measure of angle 2, then I can say that FG, that arc, is congruent to JH, that other arc. Okay, that's what that's telling us. Now let's take a look at number 4. So these are pie charts. You've seen them before. It's used to kind of separate out data. So we want to refer the circle graph to find each of these measures. So first it wants us to find CD. So CD, okay, we're talking about volleyball. We want to figure out what is the arc length on the circle graph for volleyball. So when you put this into a computer program, this is the calculation that it's doing. So I see that it's representing 18%. So that's 18% out of 100 total percent. So what we're going to do is we're going to set up a proportion. Our arc length needs to be x out of the entire 360 degrees it takes to go around the circle. So you take the percentage over 100 and set it equal to x over 360. So now we're going to cross multiply. So I end up getting 100x is equal to 360 times 18, which is 6,480. So now I need to solve for x, so I'm going to divide both sides by 100, and I end up getting that x is equal to 64.8 degrees. Okay, so our label on that now is degrees. All right, let's go ahead and let's take a look at the arc length BC. Okay, so we look at BC, and I see that BC, now we're talking about track and field. So now we want to figure out the arc length of the track and field. So I see that again, it's 18%. Well, we just did 18%. We took 18 over 100 is equal to x over 360. Sorry if you want to do more math, but I personally already know the answer. So I know that x is 64.8 degrees because we just did that on the previous problem. Now let's take a look at angle or arc length EF. So now we're talking about soccer. So soccer is only 14%. So we're going to do 14 over 100 and set it equal to x over 360. And then again, we're going to cross multiply. So I get 100x is equal to 14 times 360, which is 5,040. Then I'm going to go ahead and divide both sides by 100. And when I do that, I end up getting 50.4 degrees. Okay, 50.4 degrees for number 4. All right, last but not least, let's take a look at number 5. So we want to find each of these arc measures. So first thing we want to find is AED. Well, remember that if you have that square, that means it's 90 degrees. So to get the measure of AED, we just have to take 90 plus 63, because the E tells us we need to go about it that way. Well, 90 plus 63 is 153 degrees. So there I have a minor arc. Next, let's take a look at a measure of ADB. So now we're going all the way around this way. Well, first thing I notice is that this right here is a semicircle. So that's 180. Okay, I see that it's half the circle, so that's 180. Then I just need to take and add the 63 portion to get that arc length. And when you add those together, you get 243 degrees. All right, last but not least, let's take a look at measure of ABD. So ABD. So this one gets a little tricky. First of all, I see that I have a semicircle there, so automatically I know I need to add 180 at some point. But I need to figure out what this little nugget is. And that's where it gets a little bit confusing. Well, this angle actually has to be congruent to this angle because they're vertical angles. So that guy right there is also 63 degrees. Then we know that this one is 90. So how do we get this little nugget in there? Well, I notice that These three angles that I just found add up to 180. So I have 180 is equal to 63 plus 90, and let's just say plus x for that little bit there. So then when you go through and solve for x, you end up getting that that angle right there is 27 degrees. So now if we're going to go back and complete our problem here, we have this original semicircle here for the 180, and then to get to the rest of D, we need to add that portion there, which is 27. So we get 180 plus 27, and that's going to give you 207 degrees. Okay, so that concludes your note video today. Go ahead and show me your note sheet when you are done. Thanks for listening.